recording. And today we're going to look at probability distributions. And in this chapter, we're going to talk about a couple of probability distribution, the binomial distribution and the Poisson distribution. There are a couple of special types of probability distributions. And at this time, I want to open up the slides. So I'm going to go to the share screen. Okay. All right, so in this lesson, we'll take a look at probability distributions. And here are just a couple of definitions. The first definition, and something you hear me say, is a random variable. And a random variable, it's a variable. It's something that, and a variable is anything that's unknown. It's typically represented by x. And it has a single numerical value. So your random variable must be assigned to a number. Okay, no categories or anything like that. A random variable has a single numerical value. It's determined by chance and for each outcome of the procedure. Next, we have a probability distribution, and a probability distribution, it gives the probability for each random variable. It's often expressed in the format of a table, a formula, or a graph. I believe in chapter 2, we looked at frequency distributions, and we looked at cumulative frequency distributions, and those distributions were set up in a table format. A probability distribution is much the same. Okay, they're set up in a table format where we have one column, we would have our random variable, we'd have another column, and previously though the other column contained a frequency. In these probability distributions, that second column will contain what's called the probability. There are two types of, and this is supposed to read random variables. There are two types of random variables we're going to look at. We're going to look at something called a discrete random variable and a continuous random variable. A discrete random variable is anything that's countable. For example, the number of times a coin is flipped and the number of times heads is shown. If we were to flip a coin, the number of heads that were flipped, that's a countable set. There's no in between. There are either 5 heads, 3 heads, or no heads. Okay, whatever the case may be. Point being that the number is countable. There is no in between. A continuous random variable has infinitely many values, and the collections of values is not countable. For example, time is a continuous variable. Let's say the time it takes you to drive to work. The reason why time is a continuous variable is because there is in between on time. And what I mean by that is, let's say it takes you 30 minutes to get to work. Does it take exactly 30 minutes, or could it take 29 minutes, or could it take 29 and a half minutes? The in-betweenness, because there are infinitely many values between 0 and 1, okay? If there is infinite number of values, or if there is some in-between, then we have what's called a continuous random variable. Weight is also a continuous random variable. On one scale, you may weigh 131 pounds. On another scale, you may weigh 131.6 pounds. On another scale, you may weigh 11.2. Since that varies and it's not quite countable, right, because there's infinitely many values, weight is also considered to be a continuous random variable. And so these are the two random variables that we're going to discuss. In a probability distribution, and keep in mind a probability distribution can be a distribution that consists of random variables, it can consist of discrete random variables or continuous random variables. But no matter what the random variable, there are three conditions. The first condition is that there is a numerical random variable x. Okay, so here again, the random variable x has to be a number, okay, not a category. The second condition is that the summation of p of x, and we're going to talk about this notation, p of x is actually probability notation. So if you were to add up, so summation means to add, all of the probabilities in your probability distribution, those probabilities must all together equal 1. And the third condition is that for each individual random variable, it must have a probability between 0 and 1. Okay, so here's just three conditions about any probability distribution. So let's take a look at an example. Here we're going to consider tossing two coins. So in the chart below, we have two columns. In the first column, we have our random variable x, right? So the random variable is the number of heads when two coins is tossed. When two coins are tossed. We can either have 0 heads, 1 heads, or 2 heads. In the next column, we have the probability, P of x. When 0 heads are tossed, the probability is 0.25 or 25%. When 1 head is tossed, the probability is 50%. And when 2 heads are tossed, the probability is 25%. Okay. So now if I go back to one slide, does this constitute a probability distribution? Okay, well, let's check the 3 steps. The first step says that the random variable must be numerical. So notice in our particular probability distribution, our random variable is 0 heads, 1 heads, or 2 heads. The second condition is that the summation of the probabilities must equal to 1. So if I look back at my probabilities, and if I were to add up my probabilities, 0.25 plus 0.5 plus 0.25, they would equal to 1. So my second condition is satisfied. And my third condition states that for each random variable, it must have a probability between 0 and 1. So if I look at my first random variable, 0, it has a probability between 0 and 1. My second random variable has a probability between 0 and 1, as well as my third. Okay, so this is a probability distribution. And we're asked 2 questions. What is the expected value? And the expected value is just another way to say mean. And we're also asked to find the standard deviation. Okay. So at this time, I'm going to pull up the calculator. All right, and while I'm pulling up my calculator, if you don't have yours, you may want to grab it. Okay, now I think I'm where I want to be. Okay, and we're going to find the expected value or the mean. Now, when we were dealing with frequency distributions, we also found the mean and the standard deviations of those distributions. The way that we find the mean and the standard deviation of a probability distribution is much the same. We will simply enter in our calculator. The very first column is L1. We'll enter in the second column is L2. We'll go into our one variable statistics. We'll we'll put in list 1, list 2, and we'll pull out the mean and the standard deviation. Okay, so the same thing we did for the frequency distribution, we will do the same thing for the probability distribution. All right, so the first thing I'm going to do is go into my list. So I'm going to hit stat and enter. All right, and that brings me to my list. Okay, I'm specifically dealing with list 1 and list 2, and I want to clear out these two lists. So to quickly clear out my list, I'm going to go to the very top of my list. I'm going to hit clear and enter. I'm going to do the same thing for list 2. I'm going to go to the very top and hit clear and enter. Okay. And now I'm going to put in my first column as 0, 1, and 2. I'm going to put in list 2 our probabilities. Okay, 0.25, 0.5, and 0.25. Okay, I'm going to go back to the home screen. I'm going to go back into stat. I'm going to scroll over to calculate. We're going to calculate the one variable statistics. Right, from this point, I want to insert L1, comma L2. So keep in mind, if you have a TI-84, I believe the steps are a little bit different. Okay, so I'll pull up my handheld 84 in a second. Right, and I'm going to hit enter. All right, so the mean, remember, is X bar. So the mean or the expected value of this probability distribution is 1. The standard deviation of this probability distribution, okay, this would be sigma sub x, is 0.7. So if you're given a probability distribution, and if you're asked to find the expected value or the mean, as well as the standard deviation, these are the steps you will follow. Now, just for those that have the 84, just to show that on the 84. All right, I don't know how good you all can make this out, but I'm going to go in the list much the same way. I'm going to hit stat and enter. And I'm going to clear out those lists, list 1 and 2. 0, 1, and 2 for list 1. 0.25, 0.5, and 0.25 for list 2. I'm going to go back to my home screen. And now once I go back into stat and over to calculate the one variable statistics, for list, you should put in list 1. For frequency list, you want to put in list 2. So I'm going to hit second and 2. And then we can go down to calculate. All right, and here we have the statistics. The mean X bar is 1, and the standard deviation is 0.7. All right, so in the first half, we just looked at the two types of random variables, the conditions for a probability distribution, and how to find the expected value or the mean and the standard deviation of a probability distribution. Okay. All right, so I'm going to go back to our shared screen. And now we're going to talk about a special type of probability distribution, and it's called a binomial distribution. And in a binomial distribution, it allows us to deal with any circumstances in which we only have two outcomes. The outcomes can be heads or tails, acceptable, defective, survived or died. You could have things as yes or no. You can also have binomial probabilities that determine male or female. Okay, there specifically would have to be two outcomes and only two outcomes. Right, so in the word binomial, notice that bi, the prefix bi is two. All right, so we're dealing with two outcomes. Now here are the conditions for a binomial probability distribution to exist. Okay, each binomial probability distribution must meet these four requirements. The first requirement is that the procedure has a fixed number of trials. So if your trial consists of selecting 5 patients, right, choosing 2 colors, right, that sort of things, there's a fixed number of trials. The second condition is that the trials must be independent. Okay, that means that one outcome does not affect the other outcome. And a lot of these problems, you'll see the word with replacement. Okay, so if you have replacement, that means if you were to choose one card from the deck and then to put that card back and then select another card from the deck, the selection of the second card won't be affected by the selection of your first card. The third condition is that each trial must have outcomes classified in 2 categories, either success or failure. And then lastly, the probability of success remains the same in all 4 trials. All right, so we're going to take a look at a probability distribution, and we'll sort of see if it meets all 4 of these requirements. Okay, on our next slide, that's not actually supposed to be there. Okay, I don't know how that chart got in there. All right, so now we'll look at some notations for a binomial distribution. So once that we've determined we have a binomial distribution, the next thing we'll do is we'll have to pull out these particular quantities. We would have to pull out X, we'd have to pull out P, we'd have to pull out Q, and we would have to pull out N. X would be the specific number of successes. P would be the probability of success. Q is the probability of failure. The probability of failure is 1 minus probability of success, 1 minus P. And N would be the number of trials. So as we deal with a binomial probability distribution, we should given all four of these quantities. Okay, once we're given all four of these quantities, then we'll be able to determine some probability. All right, so we're actually going to look at an example in a second. Okay, but there's a lot of buildup for, or a lot of background for our binomial probability distribution. Okay, now we'll look at the mean and the standard deviation for a binomial distribution. And there are these formulas. The mean, which is mu, is n times p. So if I go back a slide, remember that n is the number of trials and p is the probability of success. Okay, and you'll be given n and p in your problem. If you multiply those things, you have the mean. The standard deviation, which is sigma, is equal to the square root of n times p times q. Right, so we've already determined that n was the number of trials, p was the probability of success, and q is the probability of failure. Now, a lot of times you won't be given q, but you can calculate q based on p. Right, so we're given our p-value. In order to calculate q, we can use the formula 1 minus p, and that will give us q. All right, and the variance is the square root of the standard deviation, so the variance is n times p times q. And lastly, we have, I guess I'll leave this in here. There's actually two ways or two formulas we can calculate binomial probabilities. One method is this formula. So p of x is equal to n factorial divided by the quantity x minus n factorial times x factorial times p to the x times q to the n minus x. Right, so this is one formula you can use. However, there is a much simpler formula that can be used to find binomial probabilities, and this is the formula that we're going to use. P of x is equal to, so notice that this is our notation for a combination, right? N choose x times p raised to the power of x times q raised to the n minus x. And so keep in mind that n is the number of trials, x is the number of successes, p is the probability of success, and q is the probability of failure. All right, so now we're going to take all of that into account, and we're going to look at a problem. Okay. So I know we kind of went through a lot just now as far as definitions and terms, but we'll kind of revisit those as we answer these questions. All right, so we have a Twitter example, and this example reads, when an adult is randomly selected, and this is with replacement, there is a 3/10 probability that that person knows what Twitter is. Suppose that we randomly select 5 adults and we want to determine the following. We want to find the mean, we want to find the standard deviation, we want to find the probability that exactly 3 people x equal to 3. We also want to find the probability that 3 or less know what Twitter is. So that's a probability that x is, this should be less than or equal to 3. All right, so I'm going to go to the document camera, and we're going to calculate some things. All right, so from what we talked about, let's determine if we have a probability distribution. Okay, I apologize. I guess we should do this from this screen. All right, I'm going to go back to the conditions for a binomial probability distribution, which is here. All right, so the procedure has to have a fixed number of trials. So I'll go back to our example. So do we have a fixed number of trials? And the answer would be yes. Our fixed number of trials is 5, because in this example, we are selecting 5 adults, right? So we're going to repeat this selection process 5 times, right? So n is going to equal to 5. The second thing is that the trials must be independent, meaning that one selection doesn't affect another selection. And is our experiment independent? And the answer is yes, because it says it's with replacement. Each trial must have 2 outcomes, either success or failure. Right. So what are the outcomes in our experiment? Well, there's 2 outcomes. The person either knows what Twitter is, or the person does not know what Twitter is. All right, so there's only 2 outcomes. And then lastly, the probability of success remains the same in all trials. Notice that the probability for success is 0.3, and that 0.3 is for all 5 of our trials. All right, so this does constitute a binomial probability distribution. Okay, so that's the first thing. We just went through the 4 conditions. All right, now we're going to do some calculations. We're going to find the mean, we're going to find standard deviation, and then we're going to calculate another a couple of probabilities. Okay, and we're going to do some more as well. Before we calculate any probabilities or the mean or standard deviation, we need to pull these things. We need to pull out the number of trials. Okay, so as I'm going through these things, I'm writing on the document camera. Okay, the number of trials is 5, so n is equal to 5. Because there's 5 trials. P is equal to 0.3. Right? If I go back, it says that there's a 0.3% probability that the person knows what Twitter is. So P is 0.3. X is the number of successes. Okay, we're going to talk about that once we get to the latter 2. Q is the probability of failure. So Q is going to equal to 1 minus P. So 1 minus 0.3 is 0.7. Okay, so I'm going to go back to the document camera. All right, so this was the Twitter example. We had n equal to 5, p equals 0.3, q equal to 0.7. So the first thing we were asked to do is find the mean. Well, from the previous slides, the mean, which was mu, that was equal to n times p. So in order to find the mean, I'm going to substitute n for 5. I want to substitute p for 0.3. So once I multiply 5 times 0.3, I get 1.5 as the mean. Right, so from our formulas, we simply multiply n times p. Now we'll find the standard deviation. So B, find the standard deviation, which is sigma. So again, sigma was equal to the square root of n times p times q. So n is 5, p is 0.3, and q is 0.7. So that's 5 times 0.3 times 0.7, and we get 1.02. All right, so any questions about the mean and the standard deviation? Okay, we are also asked to find the probability that exactly 3 people know what Twitter is. All right, so I'm just going to write the information again. This is Twitter. N is equal to 5, P is equal to 0.3, Q is equal to 0.7. Find the probability that exactly 3 know what Twitter is. All right, so there was a formula, and this was the formula. It was P of X is equal to N choose X times, so I'm going to put a multiplication dot, P raised to the X times Q raised to the N minus X. So what we want to do is we want to use this formula And we want to find P of 3 because we want exactly X is 3. So I'm going to go back to my formula, and wherever I see a X, I'm going to substitute with a 3. Wherever I see an N, I'm going to substitute with the 5. Wherever I see an X, well, excuse me, wherever I see a P, I'm going to substitute that with 0.3 and Q for 0.7. So it should look something like this. 5 choose 3 times 0.3 raised to the third power. I'm going to put that in a set of parentheses. Times 0.7 raised to the n minus x. So we have 5 minus 2. And I'm going to put that into the calculator. Right, so I'm going to, let's see. All right, so we're calculating number C. Find the probability that X equals 3. So I'm going to turn on my calculator, and I'm going to clear out my home screen, and I'm going to enter in the function 5 choose 3 times 0.3 raised to the third times 0.7 raised to the second power, right? Because, excuse me, raised to the third power, right? Because 5 minus, I'm sorry, that's 0.7 to the third power, because X is 3 and not 2. Okay. All right, so that's 0.7, which is Q. And remember, in our formula, Q is raised to the n minus x. So n is 5 and x is 3. And when I hit enter, I get 0.1323. All right, so that's the probability that exactly 3 people out of 5 will know what Twitter is. Okay. So any questions about using that formula? Now in this class, we want actually the formula, we're going to use the calculator. All right, and we're going to use something called a binomial probability distribution. That's the binomial PDF and the binomial CDF. All right, now before we actually answer this last question, I want to go to the very last problem, the very last slide in the set of notes, and this is the actual probability distribution, okay, for that Twitter data. So I just want to see how this calculator actually lines up with the formula. So let's kind of explain what we're looking at. We have in the first column the number of successes, right? And by the number of successes, that's the number of people that will know what Twitter is. All right, so we have no people knowing what Twitter is, just one person, and we had a probability. All right, the probability that 3 people will know what Twitter is 0.1323. Right, so notice that's what we calculated by using the formula. If you were to use the formula to calculate the probability of 0 successes, this is what you would get for 1 success. Right, we've calculated the probability for 3 successes. Right, and here's the probabilities for 4 and for 5. Right. So notice if you're calculating the probability of an exact number, either 0, 1, 2, 3, 4, 5, notice we'll use the PDF. Okay. So now I'm going to use a calculator to calculate the probability that exactly 3 people will know what Twitter is. All right, but before I actually do that, I'm going back to the document camera, and I'm going to write down the parameters for this function we're using. All right, in the calculator, and these are calculator commands, we have binomial distributions, and this is for the calculator. We have something called the binomial PDF. And what our binomial PDF will calculate is it will calculate the probabilities of exactly 0, exactly 1, exactly 2, exactly 3, exactly 4, or exactly 5. All right, so here are the parameters for our formula. We have to put in n, and remember n is the number of trials. We have to put in p. Remember, p is a probability of success. And we have to put in x. Okay, so we have to put in x is either 0, 1, 2, so on and so forth. All right, so we're going to use this to calculate the probability of exactly 3. So I'm just switching screens here for a second. All right, so I'm at my main screen. In order to get our binomial PDF function, I want to go into second, and I want to hit vars, which is distribution. Right, so you want to go into distribution, and I'm going to scroll down until I see binomial PDF. Okay, notice we have a binomial PDF and we have a binomial CDF. Since we're calculating the probability of exactly 3, we're going to use the PDF. Right? So now I have to put in my parameters. I have to put in n, and n would be the number of trials, which is 5. I'm going to hit comma. Next, I have to put in p. So p is 0.3. I'm going to insert a comma. And now I have to put in the value for x, and we want the probability of exactly 3 people knowing what Twitter is. And notice if I hit enter, I get 0.1323. You can find the probability of exactly 5 people knowing. Right? So if I wanted to find the probability of 5 or P of 5, I would simply go back to my binomial PDF. I would put in N, which is the number of trials, and we're selecting 5 people. We're going to put in P, which is the probability of success. So we have 0.3. And we're going to put in 5 because we want the probability of exactly 5. And notice we get 0.00243. All right, so that is the probability or the PDF. Now notice in the second column we have CDF. CDF is the cumulative distribution function. Okay, so let's see what makes this cumulative. Well, cumulative means that, hey, notice that for 0 successes, our probability is 0.16807. The probability of 1 success is 0.52822. Okay, this 0.52 was calculated by adding the probability of 0 successes and the probability of 1 success. Right? If I were to add these two things together, I get 0.528. The cumulative CDF for 2 would be this PDF of 0, 1, and 2 added together. So if I were to add all 3 of these probabilities together, I would get the CDF, right? So CDF means cumulative. It adds down, okay, or it adds the area to the left, right? The CDF of 3 is 0.96. The CDF at 3 is the CDF for 3 plus 2 plus 1 plus 0. And then lastly, the cumulative function at 5 is 1, right? And it should be. If you were to add up all of our probabilities, and one of the conditions of a probability distribution is that all probabilities must add to give you 1. So why is this CDF important? Well, the CDF is important if we were asked to find items such as these, okay, where we're dealing with inequalities. All right, so here we're asked to find the probability that 3 or less will know what Twitter is. And I'm going to admit there's a mistake on this slide. Okay, if you write this out, 3 or less should actually be x is less than or equal to. And for some strange reason, I couldn't find that less than or equal to. Okay, so what is the probability that 3 or less know what Twitter is? All right, so if I go back to my Twitter data, right, so we have the probability of 3, which includes 3 or less. So that means I would have to take the probabilities for 0, 1, 2, and 3. I would add all those up together, and I would get the probability for 3 or less. If I'm using the calculator, in order to answer that last question, I would use the CDF. So let's see how the CDF works. So we already found that the probability of 3, exactly 3, was 0.1323, which is here. Now we're asked to find the probability for 3 or less. So I'm going to use the CDF. So I'm going to go back into our distribution, which is second in bars. I want to find binomial CDF, and the parameters are the same. I have to put in N, P, and X. Okay, so I have to put in N, so N is 5. We have to put in P, so P is 0.3. We want 3 or less, so I'm going to put in 3. And notice we have 0.96922. All right, which is the exact same value as the hand calculation or the formula calculation. All right, now I'm going to go back to the document camera, and we're going to look at some more probabilities. Okay, now, so this is still using that same Twitter data. We found that P of 3 was 0.1323. We found P of X is less than or equal to 3. Right? We put that in as the binomial CDF. We put in 5, 0.3, and 3. And that gave us 0.9622. Sorry about that, I'm running out of paper. Now we're going to find some other things. We want to find P of X is less than 3. We want to find P of X is greater than or equal to 3. We want to find P of X is greater than 3. And then we want to find the probability of at least 1. All right, so these are all the things we're going to find. P of X is less than 3, X is greater than or equal to 3, X is greater than 3, and a probability of at least 1. Okay. So now in order to find these things, since we have an inequality, we have to use the CDF. All right. So let's find P of X is less than 3. So I'm going to go back to the shared screen. And this is what we want. Okay, so notice that we're looking at less than 3, so we're looking at the CDF, all right? So keep in mind when you're using the CDF, and let's say we found the CDF of 3, that was the probability for the successes for 3 and all of the values below 3, right? Because we had the equal to bar. In this instance, we want X is less than 3, right? So since I don't have the equal to bar, I cannot include 3 in my calculation. So in order to find the probability that X is less than 3, I actually want to find the probability for 0 plus 1 plus 2. So as I'm looking at my chart, the probability for X is less than 3 should point 83692. So I'm going to put it in my calculator. So I'm going to put in the binomial CDF. I'm going to put in 5, comma, 0.3, comma, 2. Right, and that gives me 0.83692. Right, so to find the probability that X is less than 3, in my calculator, I put in binomial CDF 5, 0.3, comma 2, and we got 0.83692. All right. Now we want to find the probability that X is greater than or equal to 3. Right? So that means that we want the probability for 3, for 4, and for 5. Okay, so if I go back to my chart for just a second, the probability that X is greater than or equal to 3 would actually be the probability for 3, which is 0.1323, the probability when X is 4, and the probability when X is 5. Now notice on my calculator, when I use a CDF, it gives me the area down or the area to the left. So in my calculator, I'm actually going to put in 1 minus the CDF at 2. All right, so notice if I take the cumulative probability for 0, 1, and 2, right, I get 0.83692. In order to find the probabilities for 3, 4, and 5, I can simply subtract 1. Right? So I'm going to go back to the document camera and actually write out what we're doing. All right, so to find a probability that X is greater than or equal to 3, in my calculator, I'm going to put in 1 minus the binomial CDF for N, which is 5, P, which is 0.3, and N, which is 2. Right, so notice I'm going to take the probabilities from 2 down, subtract from 1, and that should give me the probability for 3, 4, and 5. All right, so this is what I'm going to put into the calculator. All right, so just to show that, I'm going to just clear out my home screen. I'm going to put in 1 minus. I'm going to go back into distribution, and I'm going to find the CDF. We're going to put in N, which is 5, P, which is 0.3, and we're going to put in X value of 2, right, because that will give us the area from 2 to 0. Right? And if we subtract from 1, that should give us the area for 3, 4, and 5. Right? So we get 0.16308. All right, so that's the probability that X is greater than or equal to 3. All right, so notice that there was an equal in that probability. All right, so going back to the document camera, the next one we're going to find is the probability that X is greater than 3. So notice I don't have an equal to bar. So I don't actually want the probability at 3. I want it for greater than 3. So I want it at 4, and I want the probability at 5 added together. Right. So taking a look at that on the slide, we want the probability that X is greater than 3. So I want the probabilities at 4 and at 5. Okay. But remember that our CDF function gives us the function below. So in order to get the probability for 4 and 5, I want to find the probabilities for 3, 2, 1, and 0. All right, we're going to add these together. We should get this 0.969. And we're going to subtract from 1. Writing that out, we would have 1 minus the binomial CDF, and we would have 5, 0.3, and we're going to find the cumulative distribution function at 3. All right. So once we subtract from 1, that would give us the probabilities of 4 and 5. All right, so I'm going to put that in my calculator as 1 minus, I'm going to go back into distribution. I'm going to find binomial CDF. At 5.3 and 3. And we have 0.03078. All right, so are there any questions about the probabilities thus far. So I want to show you some rationale and a concrete example. So we sort of use the table, right? And remember, those values in the table can be found by simply using the probability distribution formula. We calculated these using the binomial PDF. So notice the binomial PDF is only used to find the probability at exactly a number. When you're asked to find the probabilities that uses inequalities, you must use the CDF. And you must keep in mind that the CDF is the cumulative distribution function, and it gives you the probability for a particular x value down to 0. Okay. All right, so if we're looking at greater than or greater than or equal to, we have to subtract from 1. All right, now let's look at this last one, because you'll see this a lot. This is you'll actually find the probability of at least 1. And in a nutshell, the probability of at least 1, it actually equals to 1 minus the probability of none, or the probability of 0. So if I were to apply that to this problem, if we wanted to find a probability that at least one person out of our 5 trials knows what Twitter is, we will find that probability by using 1 minus the probability of 0. Okay. So I'm going to go back to the shared screen for just 1 second. Right. So if we use that same rationale, the probability of at least 1, right? That would be the probability for 1, 2, 3, 4, and 5. Right? We would add up all of these probabilities. In order to find the probability at 5, right, we would use the PDF, and this is the reason why I can use the PDF or the CDF, because the probability at 0 is 0.16807. The cumulative probability is also 0.16807. Right? So if we have 1 minus the probability of 0, that would give us the probability for 1 to 5, or in other words, that would give us the probability of at least 1. So to find the probability of at least 1, I'm going to put in 1 minus, and I'm going to go back into distribution. I'm going to use the PDF. I'm going to put in the number of trials, which is 5, the probability of success, which is 0.3, and we want the probability at 0. So the probability of at least 1 would be 0.83193. All right, so at this time, I'm going to stop the recording.